everybody. Thanks for coming to my talk. I always find it interesting at conferences where there's a wide range of choices for the session to go to. What made you choose this talk over another? Because really, when we make a decision, that's what it comes down to, is something stood out a little bit more than all the other things. And so hopefully attending today, we'll learn something together, and you'll get out of it what you might have in mind or what you're hoping for. So yeah, we're going to be talking about securing secrets today in source code and in our applications. Again, my name is Gary Rogers, and I'm a software developer at Adobe. I've been with Adobe for about 3 years, and I work with on the Marketing Cloud Web Services team here in Lehigh, and we're responsible for the APIs for the Marketing Cloud. So you might be familiar with like Analytics or Site Catalyst or products like that, the APIs for those points. So I want to start out with a story called $2,375 Amazon mistake. Some of you guys that are close to the ground on the security front may have heard of this story. It came out last fall, late last year, I want to say, and essentially it involved there was a guy that was building a Ruby on Rails application, just kind of learning how to build it and doing a tutorial. And he wanted to put the code for this application that he built up on GitHub. So he went about coding it up. And if you've ever done any Rails development, there's some configuration files. One's called application.yaml. And he accidentally put his Amazon S3 credentials in the application.yaml file and committed it and pushed it up to a public GitHub repository. And fortunately, he realized his mistake within just a few minutes, like, oh, I just put my private Amazon credentials in a public repository. I better fix that. So he made the changes, and thought he changed the GitHub, the Git repository history, and then he uploaded those new changes and thought that all the history was gone and nobody would be able to find it. And then he went to bed. Unfortunately for this man, his nightmare came when he woke up in the morning. He noticed he had, I think he said, just tons of urgent emails from Amazon and a phone call. They tried to reach him during the night. And he came to find out that there were 140 EC2 instances running on his AWS account just through the night. And so, surprised and horrified, he found out that that someone they obtained his credentials from his GitHub repository. Turns out there are bots that are continually crawling GitHub and looking for these types of mistakes or people that accidentally commit credentials to a source code repository. They grabbed that information and within just like 8 hours had spawned up 140 servers running a Bitcoin mining operation. So, so that was a $2,300 lesson. I think the guy was able to get Amazon to reverse the charges, but it's just a nice little case study example of what not to do, and just that we need to, a reminder for us all that we need to be very, very careful and cognizant of where we send secret information, who has access to it, where it goes, and because sometimes even just one time of it falling into the wrong hands or getting saved to the wrong place is too much. Let's see. So when we're talking about a secret, if you're not familiar, we're talking about account credentials, passwords, passphrases, private keys, certificates. And I say certificates because sometimes, most of the time, a certificate is not a secret. Certificate is offered in a browser exchange or other implementations of OpenSSL. But sometimes those secrets, or excuse me, those certificates can have the private key for the certificate embedded in the file, depending on what format it's in. So you just have to be a little bit careful when you're exchanging certificates. And then I haven't listed public keys. Public keys are public; they're not secret, so they wouldn't fall under this list. So the other thing is that at points of this talk, it's going to be a little bit of a panel or just like question and answer. I want to get some feedback from you guys. How many in here are software developers or build code on a day-to-day basis? About half, looks like, a little more. So when we're developing code, when we're making applications, how do secrets end up in the source code? First of all, just raise your hand if you've ever committed like a password or some sort of secret information to a source code repository. I know I have, so just full disclosure. So how do they end up there? Like, what are some of your thoughts?
Well, and for us, what it was is that like all these Rails applications got all these configuration files, and to make your stuff work, you gotta get in there, and then you're not thinking, oh, I need to swap that out before I commit, or I use something else, and so you get push, and
Yeah. So sometimes like the secret is just kind of an afterthought. When you're building something, you're just focused on getting it working, not necessarily how it's organized or how the secret information is stored. It's kind of a second thought or an afterthought. Any other thoughts? Or
just during prototyping, careless, hurrying to prototype things and then getting things working and forgetting that some of this was just kind of sketched in and prototype.
Mm-hmm. So like something that was more intended to be a little bit more temporary or at least not permanent ended up that way. Yeah, that's a good one. Any other thoughts?
You see someone else who's already committed a password and kind of sets precedent.
Yeah.
Well, I guess it's out.
Yeah, we don't always have the luxury of building apps from scratch and making the right decisions up front. So yeah, when an application already has passwords and stuff committed in the source code, database passwords are probably the most common. It's easy to be like, well, it's already in there, so I'm just going to add on to the pile, jump on the pile. And so, years down the road, you end up with this big mess of really sensitive information in the application. Any other hands? Yeah, those are really good reasons. Let's see. I wanted to just pause here and go over to GitHub. I don't want to pile on GitHub. GitHub's a really great resource. It's just because because it's so highly used and there are so many applications and source code on products such as this, it just makes it a really, really easy target or low-hanging fruit to find sensitive information. I don't know if you know about GitHub or have used it, but they provide a really handy search feature just right on the home page of their application. So let's say how about I put it over here? So github.com, just this search, they have a search API. You can use it here in your browser. They also have a publicly available API that you can use to search and get responses back on their thing. So let's just put in DB password in their search field and see what we come up with. Okay, then you can go ahead and you can do like select the code. So this is just going to search for instances of this phrase among all the source code files that are publicly available in GitHub. And since I'm going to be talking a little bit about PHP today, we'll go ahead and select PHP, and you can kind of peruse this. Let's go to page 3, get some really juicy stuff in here. Whether these are intended to be there or not, they might be dev credentials, they might be who knows what. The point is that there's probably a lot of stuff already on GitHub that wasn't supposed to be there. And for probably many of the same reasons that we just listed. A lot of these are probably open source tools or copies of open source tools that people are working on. But it's just easy to forget when we're working in a public sphere or a sphere that people that we may not want to have access to that information might be able to get access to that information. And GitHub is just like a huge public example, but I would argue like even within the companies that we might work for, it's not a good idea for every employee to have access to all the information. And sometimes passwords might provide gateways or avenues for people to get access to systems that their jobs or roles or they're not supposed to have access to. And it's not that everyone shouldn't be trusted. It's just that passwords help define those boundaries of trust, and we don't want to blur them by polluting them out there to wherever they shouldn't be. Okay, let's see if we can get back to the same spot here. So with that, I think it's important to ask ourselves, what is what is our application's stewardship? So any of the apps that you might work on or things that you're building or planning to build, what are they supposed to be stewards of? Like, what information do they are they responsible for, and are they asked to maintain? And if you start thinking about the components of that application, whatever the use case is, I would again argue, and it's probably safe to suggest in most cases, not all cases, but not in that list is the task of keeping secret data. Like, it shouldn't be your application's responsibility to maintain, at least from a source code perspective, passwords to systems that application uses. I'm not talking about user accounts because like most applications, you need to log in users. You need to let individual users use the application. I'm talking about like systems that application might have access to, like databases or file systems or other APIs or resources that the application consumes. It's not the application's fundamental responsibility to maintain the security of those systems. And an analog for that example would be like the credit card payment processing. Like, let's say you have a payment processing application or a component of an application. No longer is that the application's job to retain and store credit card information, at least in plain text. Due to industry regulation like PCI compliance and others, I think most cases we've successfully pulled those two layers apart, where it's no longer a specific application's job to keep credit card information in a form that can be used or accessed by other systems. So another thought here is, as a developer, do I need to know the database password? And I'm talking about in dev, yeah, in a development environment, of course we do, because we're under the hood working on things. But outside of a development environment, do I even need to know or care what the other environment passwords are? Nope. And so if I don't need to, I mean, the application does like just in time right before it runs, but like I don't even want to have that like ethical responsibility of losing or compromising that password, especially for the production environments. So if I don't want it and the application doesn't need it until just in time, like it doesn't even come close to make sense to put it in the code. So let's see. Oh, the other thought here is that the more often that we distribute a secret, so like the more often we're distributing a password, or the more often we're sending around the source code that has that information in it, just from a probability standpoint, it increases the chance of that information becoming compromised, because we're passing it along potentially an unsecure channel, or we're giving it to somebody that might get their laptop stolen, or any number of issues. It's just the more touch points you have on that secret information, the greater the chance of it becoming lost. Let's see. Okay, so what we need is something that can solve this challenge for us. We need something that can, well, first of all, we need just a wholesale, complete removal of plain text secrets from our application. If it's in a YAML file, if it's in the code, if it's in a text file, if I'm talking about if it's embedded in something that permanently lives with that application, it shouldn't be there. And in order for us to do that, we need a tool for a privileged developer, a privileged user, to add and save encrypted secrets, or encrypt this information so that it can't be utilized by untrusted parties. And then we need part of this tool, a way it would be nice for a non-privileged developer to view the names of those secrets that have been added. So they wouldn't necessarily be getting the value of those secrets, but they would be able to see which ones have been committed to and encrypted in said system, so that they could say, oh yeah, somebody's already added the database password. I can just go ahead and reference it with this name and build that reference into the application. And then finally, in order for this to work, we need a mechanism within our application so that we can load those secrets at runtime, just in time, right before we need to access the resource that password or secret is protecting. So I just want to encourage us that there is a way to do this. This is not a new problem. This is kind of a fundamental challenge that goes along with software development. It's something that's existed in the industry for probably decades and will continue to be a problem. And so it just kind of is an effort required from all of us to make it better, to make a difference in our own spheres, and learn better ways to protect this information, and then you can make a difference. I wanted to provide a quick primer on asymmetric encryption in case you aren't familiar. Asymmetric encryption involves two components, a public key and a private key. And they are involved in the encryption and decryption of clear text. So here in this image, you have clear text coming in. The private and public key are generated at the same time. So some key generation action produces both of those files. And then the public key can be used to encrypt that clear text. And then you have the encrypted data there, that pink square on the top right. This is a fundamental principle of asymmetric encryption done this way, is that that encrypted data cannot be decrypted by the public key. It's a one-way encryption algorithm. And so you need the private key to decrypt that data, and then you have clear text again. So this is one way you can't go both. I mean, you can, there are some things that you can encrypt with the private key. So I'm not saying you can't encrypt it all with the private key. What I'm saying is the proper use of asymmetric encryption is one way, and it provides a nice way for this to work because you can share the public key with anyone. There's nothing you can do with the public key other than determine the private key's bit size and encrypt the data. So it becomes really useful to receive data from somebody else that you wouldn't want anybody else to have access to that doesn't have the private key. So a model solution that we can use with asymmetric encryption is this multi-host environment, and this is incidentally very similar to how the OpenSSL, or rather the TLS exchange works. I won't get into too much detail there, but we can also leverage this application, this model in our protecting secrets in our source code. So essentially, you have these two hosts, host 1 and host 2. Host 1 in this case would represent our application environment, like production, testing, or dev, if we want to test in dev the operation of this model. And host 2 would be like our source code host, our place where we're storing source code, be it GitHub, SVN, a dev workstation, wherever you're storing your source code would be host 2. So you would, in this model, distribute the public key to host 2 or whatever other hosts are using that code, and they can encrypt data with that public key and store that encrypted data in whatever system that they want. Once it's encrypted, nobody else is going to be able to use that information. And then that encrypted data can be sent over an insecure channel. It can be sent over the internet. It can be sent over email. It can be sent over, a laptop. If it gets stolen, it's not a big deal. The point being that the decrypted data is eventually delivered to the application environment, and then the application environment retains a copy or the only version of the private key, and then that private key is in turn used to decrypt and return plain text. So, Brent, go ahead.
Well, I just wanted to mention, this seems like it would also be awesome even if your host 2 was private, because it requires an attacker to have two pieces of information instead of one. So even if they're able to obtain the private key or obtain the encrypted secret, they have to have both in order for it to be useful to them.
Right. That's correct.
So yeah, it's a good model in general.
Yeah, and I didn't come up with this model. This is, kind of asymmetric encryption 101, but go ahead.
I want to jump down a little bit here, maybe a little bit. There's a problem with this solution, and that is if the public key crypto system ends up having vulnerabilities or weaknesses, and your public key and the encrypted password are pushed to GitHub, those with the power and the access to break that crypto system will get access to password?
Sure. Yeah, there's no such thing as a bulletproof security model. If I just destroyed all your hopes and dreams, then sorry.
Not to say that's private now. but
Right.
it's still something to think of.
Absolutely. You bring up a good point is that security threats, they're continually evolving. So like just because this works or a implementation of this type of model may work for you, it doesn't mean it will always work. It doesn't even mean it will work tomorrow because this is an arms race that we're dealing with in security is that the mechanisms to protect stuff gets better and then the threats and attack vectors to gain access to those protected systems gets better and stronger, and it's just always evolving. That's just the nature of the beast, and so it's important to stay abreast of changing things and making sure that your systems for generating these key pairs and storing and exchanging the private key is hardened so that you limit your vulnerabilities.
Yeah, I was going to mention, I heard a security guy speak on this topic. He basically said the objective is to be more secure than the next guy so that the amount of hours it takes to hack your system makes it not worth it for a hacker to do it, because it will almost always be possible to hack your system, but you don't want to be the low-hanging fruit.
Right.
So it's almost like, if you're running from the bear and you want to be just faster than your friend, you don't need to be faster than the bear.
Right. So like the lowest hanging fruit is unencrypted stuff. Then like maybe the next lowest hanging fruit beyond that is like poorly encrypted stuff or poorly implemented encryption or weak keys or keys where the key stores or the key generation process isn't hardened correctly, and then it goes up and up from there. But yeah, thanks. Any other thoughts? Did someone else have
I
their hand
don't know
up?
if you're getting to this, how we solved it, because we had passwords in our Git repository.
Mhm.
We, instead of loading those configurations with the YAML files, is now we load it with environment variables. They don't
Mhm.
never see our GitHub repo because those environment variables only hit the system at the point of deployment.
Yep, that's one way to do it is if it doesn't need to be there in the first place, and you can kind of skirt around it by putting those environment variables. You still have to be a little bit careful there because those environment variables have to be defined somewhere in some system or in some other place. So if all you're doing is moving it from this system to this other system, you really haven't still solved the problem. It's just you just put the problem in a different place. But yeah, that's one way to do it is to separate a configuration system from your application. So yeah. Did you have a comment? No? Okay. Okay. So this is just a PHP example of what we're trying to avoid. I think we've kind of touched on this already, but this is just a simple PHP script that connects to a Mongo database, and this is just purely for example, but here we have a connection string that has the user dev : my password just committed right in there to that script, and then we load the database and get the user, and you can have my email address if you want it. So, but yeah, I mean, this kind of stuff is all over the place, especially if you work in an enterprise environment, just because stuff changes so rapidly, and for all the reasons that we are already listed for why these end up there. This is just what we're trying to avoid. So if you see stuff like this, then this is what you need to fix. And by the way, one of the problems that arises with, and this is aside from some of the principles that we've already talked about, but have you guys ever had to go through a password change in a production environment, especially on an application where you have lots of committed passwords? I mean, it's kind of like this, right? Everybody gets mad when you start talking about changing passwords because like, wait, if you change it, then this is going to go down. So like, it's just the unfortunate reality that comes along with committing the passwords in your application is that you've also made the password a dependency of your application. And so now changing it is a huge challenge. And so that's where the model that this gentleman in the front row brought up just a bit ago helps out a lot if you separate it to configuration service, because then you only have to change the password in the configuration service rather than making a code change. Okay, so I want to get into the next phase of my talk. It's on this solution that I'm calling Portunas. Portunas is just the god of keys, the Greek god of keys. And this is a solution that we've been using at Adobe on our team for a little bit, and it's worked out okay for us. This is just a solution. It's a solution that I came up with in PHP. There are comparable solutions in other platforms. They may or may not exist depending on what you're using. But the purpose of this demo is not to show off this tool. It's really just, I want it to serve as a means to illustrate the concept and just a way to deal with encrypting passwords in your source code environment. So you can take it for what you will. It's open source, so you can use it or hate it or whatever. But just don't get too caught up on this thing itself. It's just, like I said, it's a way to illustrate the concept. So here we have let's make this full screen so we can see it better. Is the text size okay there? Here we just have this little demo application. It actually uses the Slim framework, and we have some source code that looks very similar to what I was showing you earlier, just a quick little web application. I'll start it up here in a second. So I'm just going to download this. I'm going to go through some of this stuff a little bit fast. It's not necessarily a walkthrough. I just kind of want to show you what's possible here. So download this little guy. Open it in. So all we have here is just a Composer file. If you've never used PHP or Composer, Composer is just a dependency manager for PHP, similar to NPM or others. If I can find the terminal here, we'll just load this guy. Oops, I changed. Let's see. So just going to pull in the Slim framework, or excuse me, the Silex framework here. I said Slim, but I meant Silex. And that's going to drop in some vendors here. And I believe I have my database running here on localhost. We'll give it a try. See, looks like we have localhost 8080.
You just web/web.
Oh, thanks. Yes, I do need to do that. Okay, well, in such file or directory. Sorry, I don't like the sound either, but it's not letting me mute it. Sending it over this HDMI. Localhost. Well, it was working a minute ago. Okay, this is new. Failed to connect. Demo app failed. I think I changed the account, but that's okay. I don't need it to work here in dev. This is the less important thing I wanted to show you. But again, here we have the same database access string that we might be posed with or faced with solving this challenge of what to do with this. So what to do with this? There's this tool that I talked about called Portunas. This is available on Packagist and Composer. So this is the repo to get it, and the install steps are pretty simple. You basically just add the dependency to the Composer JSON, and we need to pull in these install scripts and rerun Composer. Yeah, it helps if you use Composer correctly. So this is just going to load in this library here to our demo application. And while that's loading, I'll just kind of brief you on how this works. So there's a concept in Portunas called a safe. A safe is kind of like a vault or a place for storing secret information. The safe is in this case is a SQLite database. And when you generate a safe, it produces an RSA key pair. And so you need to retain the private key when it's generated and distribute that private key however you feel like distributing it. This library doesn't attempt to solve the key exchange problem, just it helps you with encrypting and decrypting your secrets. So I think we're loaded here. Nope. Boy, I hope I have, I hope this will download for me. Let's see what's going on here. Okay, yeah, it's going. Just hung up. All right, so we've got the Portunas library in our application. You can see it here under the vendor directory. What we want to do now is to create a safe. So just run our little command here. We can list the safes that have been created. I don't know if you guys can. Can you see this okay? So there's no safes. We have a stock Portunas database here. And by the way, it just puts it in this data folder. It's called portunas.sqlite. So we don't have anything in the safe. By safe list, it returns an empty result. So we can create a safe, and it asks for a name. We can just call this one dev. And so here's what I was explaining. You get a private key. This you would want to save to a file and distribute however you need to. So we'll just save this in and call it dev.key. So now when we run safe list, then we're going to have the dev safe has been created. There are no secrets in the safe. It gives you some time information on when it was created and last updated. So again, all we've done is create a key pair and name it essentially at this point. Now, it would be great if we could store something in it. So that's done with this secret store command. And it asks what safe we want to use. It detects that we've already added the dev safe. So then we can give this secret a name. We'll call it mongo.password. And then I'll put in the password. It doesn't show the input. So now we've created the Mongo password secret. And if we do safe list, now we see that there is one secret added for the dev safe. If we do secret list, ask which safe, and you can see that there is a key mongo.password in the dev safe. And the length, this is not the length of the password. That's the encrypted payload string length, so the number of bytes in the ciphertext. And you can see when it was created and updated. So now if we actually look at that SQLite database, let's see, I think I have this crummy little SQLite viewing tool or editing tool. see the data here. You can see we have the public key is actually a property of the safe in the database, and then we have the secret. It's called mongo.password, and then there's the encrypted ciphertext. You could actually just distribute this SQLite database to just about anybody at this point. There's no harm or foul with it, because as long as you don't include it with your private key, then there isn't much danger to it. Yeah, go ahead.
So you're just, for this specific question, you're just storing it in raw binary or simplicity state rather than encoding it basically or some other key variable.
Right. Yes. Yeah. So one thing is you can do, I think this will work. It will give you, the output looks terrible because of the text size there, but you can get a signature of what the bytes, the encrypted ciphertext is. But again, because it's encrypted, it's not going to be human readable at all. You could view potentially the base64 output with it, but it's not usable at all unless you have the private key. So there's a tool that you can use on the command line called decrypt, and this will only work if you have the private key. So we can tell it we want to use the dev key here, the dev safe, and we get an error. Hooray. Well, that's okay. We don't need to decrypt it right now. So if we go back to our application, I can show you how to use it at runtime in your app. We're still not going to be able to connect to the database because I have some permission problem, but we can get the password before then. So per the documentation here on the site, you just, this is where you want to retrieve the secret in your application. So in order to do this, you still, again, you need the private key. So we're going to declare an instance of the Portunas agent class. So that's done just like this. And we need this callback defined. This callback is basically when Portunas needs the private key, you can give it to Portunas. This is just an illustration example. You wouldn't necessarily do this this way in an actual environment, but let's see. Can't type when I'm speaking. I think that should work. And then we want to get the encrypted text, and I think the key was called mongo.password. So this block of code just says, I want a new Portunas agent. I want to use the dev safe. The Portunas agent knows where your SQLite database is already. You define a callback that says, when I'm ready to decrypt text, then I'm going to call this function right here. And this function is going to load the bytes of that private key file that we saved and provide it to Portunas. And then that private key is going to be used to decrypt that particular key. So if we did this correctly and we run it, let's see. Not that. And we go back over here, see if this works for us. Parse error, line 15. What have we done here? Oh, that's not a good idea. So there we go. We have dev password, and that's the string that I put in when I encrypted it. And as you can see, let me open this back up again. Dev password is not the same as this. This is the encrypted text, as we said earlier, not usable. So this is just a way to get at your encrypted information within your application in the safe. And again, you can commit this Portunas SQLite database. You can send it to your friends. You can do whatever you want because it's not usable unless you have the private key. You wouldn't want to distribute the private key. So some thoughts here. The way we basically handle this is we have a manual key deployment process that a human has. So I'm talking about like in our environment at Adobe, we have a manual key deployment process where a human has to go in and send the private key to a location that the web application has disk access to it. And so we kind of white glove treat the distribution of the private key file, and it gets into the specific environment that's supposed to go to. And then when the application is deployed to that environment, it knows to say, like, with some environment or variable or something, it would say, oh, I need to load the production safe, and because it's in production, it would have access to the production private key that was manually uploaded. So doing it this way allows for a couple advantages. One, obviously, security that we talked about, but the other advantage is that anybody on the team can commit to the safe. They don't have to have the private key. You don't have to have the private key to add keys to the safe. As I showed you here, adding like I will just remove the private key right now to show you. So I'm going to remove the key, and we've lost it now, so we can't decrypt anything, but we can still store stuff in here. We can just say, you know, foo. And then if we do secret list, we have both those secrets stored in the safe. And we could get it if we had the key. But now, as I showed you, I removed the key, so this isn't going to work anymore. It's going to, well, I don't have the server running, but you get an exception because you've passed an invalid private key. It throws an exception on trying to decrypt it because it doesn't have the proper resources to do so. Does somebody have a question? I thought I saw maybe some hands.
I have a quick question.
Sure.
So earlier you talked about how crappy it can be to deploy a new password on a production environment and not have things break in the interim.
Right.
Does this help?
It does if you don't commit the SQLite database to your code. If you do, then you're still going to have possibly a code change to write to that safe. It's a binary file, so you've got to deal with that also. If you don't commit the safe and you just put it, say, like on some block storage system that the application has access to, then you wouldn't necessarily need to, because all you'd need to do to make a password change is wherever you have your SQLite database, just run a new store command. So, like, if we wanted to update the if we wanted to update the Mongo password, we would just do it like this. And I think I can, so I just changed the password there. It's not in the source code, and if I just use the shell history, I can recover our private key here. Is that, yeah. So now I changed, if you notice, I changed the password here to something else. I didn't make it with a code change, and if we refresh our application, we should see the new password. So yeah, to answer your question, it would if you don't commit the SQLite database, but if you do, then possibly. But yep. Any other thoughts or questions, concerns? Is anybody, I meant to ask this before, but is anybody using enterprise password management tool by chance at their operations? Just to close then, I will talk about that. There exists some enterprise password management tools, one of which I'm familiar is CyberArk. CyberArk has an enterprise vault system, and it basically performs what I just showed you with Portunas, but it's done on a much larger scale, enterprise scale. It's a fairly expensive product to use and deploy. We would be using it, except that our particular server environment doesn't allow you to run the Vault client that CyberArk wants to use. But both of these are really solid products if you're looking to go with an enterprise solution. So, and CyberArk works with Python, with PHP, with Java, with tons of different language implementations. So, any other thoughts or questions? Nope. Well, thanks. Appreciate your time today. It's good to be with you guys, and hope you learned something.